Good morning, good afternoon, and good evening from wherever you're watching us today. My name is Sinisa, Nikolic, and I'm the Director of High Performance Computing and Artificial Intelligence for Lenovo Asia Pacific. I would like to welcome you all to another in a series of quickfire discussions where we'll be joined by some of the world's leading researchers and technologists who are here to share some insights into how is intelligent transformation addressing humanity's greatest challenges. In the case of today's discussion, genomic study holds the promise to highlight medical interventions needed that were born from external influences, from lifestyle, climate, such as increase in UV radiation, etc., food security, that can affect the genes in the human body. Joining me today on this topic is Dr. Moinak Banerjee. Dr. Moinak is currently the president of the Indian Society of Human Genetics and a scientist at Rajiv Gandhi Center for Biotechnology. He specializes in research areas such as deciphering molecular pathogenesis of neuropsychiatric disorders, as well as employing genetics, pharmacogenetics, and immunogenetics in his research studies. Now, I'm actually tongue-tied already. So what I'm going to do is welcome Dr. Banerjee today. Hi, doctor. How are you doing?
Thank you, Sinisa, for such a wonderful introduction. I welcome you all to this chat show. Today, we are celebrating 20 years of the first human genome draft. And in 20 years, the genomics have changed the entire scenario of disease diagnosis. Earlier, we used to go from disease to genes. And now with the advent of the genomic initiatives globally, we are actually going to the disease from the genomic approaches there. So it is a complete reverse trend that clearly justifies that genomics has a huge potential in the coming years there, which is also evident that in 2027, the market profile of the genomic industry is believed to be around $100 billion there. So with this, I would request Sinisa to take on forward.
Wow, that's amazing. It's unbelievable actually to think that we can now go from gene to disease. I guess that forms the core component of what we call today, I guess, personalized medicine. So, Dr. Banerjee, what are some of the pressing challenges, or some additional pressing challenges that are posing risks or threats to mankind, or I should say humankind?
Yeah, in fact, the biggest challenges I can give you with an example. One of the best examples that I can suggest you is let us consider cleft lip and palate. Cleft lip and palate was considered to be of genetic disorders there, but now we get to know that this cleft lip and palate can also be induced because of certain drugs, and it can also be induced because of certain pesticides there. So therefore, whether if it's a genetic disorders, while we are considering it to be a disease or malformation, one should also think of considering whether this particular malformation is because of the pollution that is surrounding us, or is it because of the medication that the particular patient's mother was undergoing when she was possibly carrying the particular child. So this literally opens up the real challenge of a disease diagnosis and a precise disease diagnosis there. And at the same time, it also opens up whether medication should also be considered very considerately, because 90% of the medications that is FDA approved have not been tested for terrorogenic potential there. So which literally calls up that many of these medications need to be considered for its needs to be evaluated for its terrorogenic potential there. So that really talks about the challenges that remains in the genomic industries there.
That's absolutely frightening. Some of those statistics there, particularly on drug testing
Right.
and the effect on human genetics,
Right,
and the DNA makeup. Right. I mean, I think this is that's a little bit frightening.
Yeah, that's true. Absolutely true. Dr. Sinisa, so what are the real technological unleashing limitless possibilities for researchers and putting them on a fast track to solving humanity's greatest challenge. So over to you, Sinisa.
Well, so how is technology addressing some of these things, right? Yeah, it's a really good question. Look, when certainly from my experience, when you look at the healthcare sector, the digital transformation is effective. It's irreversible, right? And it is across every sector, to be honest. And the acceleration in technology use is irreversible. Everyone's just adopting technologies to ease burden and create efficiencies. If you look at remote patient care as an example, as IoT is opening doors, you're seeing this internet of medical things, or this IOMT, and they're building solutions around healthcare. And we've all experienced, certainly during the pandemic, telemedicine, when we were unable to go and visit a doctor or a clinician. We had to look on our telephones or our laptops or our computers at home. But more than that, you're seeing remote patient monitoring. So if you have areas, more rural areas, so you're seeing more of that, so you can have specialist care for patients via remote. In addition to that, we're now seeing microsurgery with robotics, both in-presence robotics as well as remote robotics. So I think those things are just technology drivers. They're being affected by 5G, so one has a great deal of bandwidth, and all of this type of work creates video, CCTV imagery plus data, and it requires an awful lot of bandwidth. But in addition to that, I guess the things that you've been talking about already are really focused around personalized medicine. And so using AI, big data, and analytics that will work together to efficiently deliver these types of insights. You've already mentioned one then, which was around drugs. So we know that certain drugs today have more effect on certain individuals than other, dependent upon their genetic makeup. So targeting drugs for specific diseases based on one's genetic makeup is life-altering. So that's one. Another case around personalized medicine that for some reason actually touched me quite deeply recently as I was reading this report was really around this child. There was a child in the United States displayed symptoms of myocarditis, which is an inflammation of the heart and effectively the diseasing and the dying of the heart. And that really happens when immune cells swarm the heart and cause damage to it. And it's usually triggered by a virus, an external influence, or stresses to the body. Now, that's treatable with drugs. However, the child was not responding. And so this particular institute ran a very fast genetic makeup or ran the gene sequence. In fact, received a Guinness Book of Records for how quickly they ran through the genetic sequence. And they noticed a mutation in a gene. And that mutation in the gene caused that same symptomatic display for the heart itself. And so when you look at something like myocarditis, that's treatable by drugs, but from a genetic malformation perspective, that's only treatable by a heart transplant. Now, in the case of this child, they found it because of this genetic work stream, very personalized, to this child. And they were able to do a heart transplant. They found somebody very quickly and did that. And that was a difference between a 13-year-old child living or dying. And so for me, that was very touching and such a very clear display of how technology is being used and addressing, addressing challenges within the human body. I thought it was unbelievable. So.
Oh, that's wonderful, Sinisa. Because I was also wondering, in an Indian scenario, a doctor spends only around 2 to 3 minutes per patient there. And whereas compared to the Western world, particularly Scandinavian countries or US, a doctor spends close to around 30 minutes there per patient there. And this AI technologies will definitely be very useful in automating the counseling process itself. So that will be wonderful, literally, if this AI methods can be developed for counseling process itself there.
Yeah,
So that,
I think it absolutely would be. And look, as we drill a little bit further into your point there, what do you think some of the other or additional benefits a research organization can realize by applying some of these advanced technologies like HPC analytics and AI to genome analysis,
yes,
etc.? What do you think?
that is actually a very, very interesting question, because to realize the implications of genomics, one has to be genetically aware there. And to be genetically aware, which is evident that globally many of the countries are becoming genomically aware, as it is also evident from the Genome India program there. So in compared to many other countries, India also initiated a Genome India program there. And even in India, they have declared that genomic industry is going to be a front runner industry in coming decade there. So that literally suggests that genomic is the core focus. And the biggest challenge in the genomic industry is about the time taken from the genome sequencing to diagnosis there. And I can tell you that from my experience, I had been using your GHOST program, and I have been very happy with it, because normally it used to take around 24 hours to 48 hours for analyzing the particular genome there. Now I'm able to do it within 10 minutes there. That's a phenomenal push forward towards the analysis issues there. And analysis is really becoming more and more challenging as more and more data comes in there. And that is where possibly there is a huge focus that where the industries can actually really take up to develop AI-based tools or ML-based tools there. So with this, I would be very keen to know from Sinisa, where are you actually heading towards?
Well, look, I tell you what, you just said some very powerful things, right? Particularly around performance. And look, according to a recent Lenovo and Intel study by IDC on decoding genomics and smarter IT, a lot of leaders such as yourself in this field of genomics ranked developing precision medicine as one of humanity's greatest challenges. And as you just pointed out, it's a game changer. Genomics research is a game changer. Absolutely. So we at Lenovo have a fairly long and storied history with HPC and specifically in genomics, as you pointed out. And I might just touch on that now around GHOST. We developed with Intel at that time this technology called GHOST. And in essence, we took off-the-shelf componentry along with the GAT code, which is an open source code, and optimized and tuned both BIOS as well as the software code to such an extent that it would just do that one thing amazingly well, effectively turning it into appliance. And I think you already hit some of those numbers, right? 188 odd times faster than most processing systems on the planet today. And that's really just because of this optimization and just that focus. And I think that is, I think that's one of the major keys, that as organizations start delving further and further into genomics research, etc., they're spending more time studying the outcome of these research projects than actually building the research project itself, if you know what I mean. Not optimizing codes, not doing this. Being able to use the technology that's on offer from organizations such as Lenovo using GHOST to derive that level of insight incredibly fast. And so, deriving insight fast allows you to run more genes. And as we start talking about population-based genomic studies, that's currently in process in a number of countries around the world, where you can do cultural related malformations and other things. I mean, you spoke about cleft palate in your opening. I had no idea that cleft palate was either from pesticides or certain drugs or location, right? And that's all location derived. It is amazing to be able to find those insights quicker and be able to generate help in the market. So I think it's technology innovations such as that ultimately will democratize knowledge and democratize data and help humanity in the long run.
Yeah, that's perfectly fine. In fact, that's what the real challenge is all about. Both the analysis platforms and even the genomic sequencing platforms there, which is actually revolutionizing the way the technology is actually driving to speed up the activities there.
Yeah.
So today we started up with a small Sanger sequencing, and today we can actually do the entire whole genome sequencing in just a single day there. That's really phenomenal there. And even the analysis also takes up a much shorter time there. So it's, I think that we are all directed towards the right direction. There has to be consensus effort from everyone. I am sure that you all are really doing wonderful work on from Lenovo side on pacing up the genomic analysis activities.
Yeah. Thank you, Doctor. I really appreciate that. Making me blush, but it's not me. It's our whole team of research and development, and a whole group of people. In fact, people such as yourself as well, right? So look, as I wrap up today's quick fire discussion, I wanted to personally thank you for sharing all the insight that you have and just that wealth and depth of knowledge, over so many decades working in this industry. Look, you mentioned a lot of exciting and fundamental changes in how clinical technologies are going to address personalized medicine and patient focus. I, for one, are feeling a little less concerned about being 54 years old today than I was yesterday, just because of that, right? So look, thanks again. And again, you've spoken about it just like 30 seconds ago, but it's you and your peers in the research, in the research areas, using the technologies that Lenovo provides that are really making those changes, I guess, solving humanity's greatest challenges and working towards them. So for that, I thank you. And really, I think the world's just become a little bit brighter. So once again, Dr. Banerjee, thank you so much. And I wish everyone a very safe and happy day ahead. Thank you so much.
Thank you. Thank you so much, Sinisa. Thank you so much.
Bye for now.
For a wonderful chat. Thank you very much.
Thank you.